Hello, I'm Robert Radishak, and this is Gregory Ward, and we are doing Biology 1 project, extra credit.
For the Hardy Weinberg problem.
Yes, let's commence. Okay, so Gregory Ward, section 11, PID G3113314.
And Robert Radishak, section 43, R3038293.
And today we're going to be looking at ear size. Our starting population, it consists of 500 individuals, 175 of which have big ears, which is a recessive trait. The remaining have small ears, which is a dominant trait. First, we will look for the percentage that are homozygous dominant. Then we will look for the percentage that are heterozygous. And finally, we will find what percentage are homozygous recessive. Let us begin.
Okay. So in the problem we were given, you were told that out of 500, 175 were homozygous recessive. So what you have to do is you have to get the decimal from dividing 175 from 500, which will give you 0.35. And for this equation, let's go back, we will be using P plus Q equals 1, and P squared plus 2PQ plus Q squared equals 1, and yes, that is a dreaded quadratic equation. Okay, so now that we solved for what homozygous recessive is, we have Q squared, because Q represents recessive, equals 0.35. Now you have to get the square root of both, so you get Q equals 0.59. Now that you got Q, you have to solve for P by using the P plus Q equals 1. So you have P plus Q equals 1. You move the Q over to the 1 so you can solve for P. So you get P equals 1 minus 0.59. P equals 0.41. So now you have P and Q. If you add them up, 1 will equal 1. Check. Okay. Now we have to move on to find the values of each. So we have to figure out what P squared is. Q squared is given, which is 0.35, and then 2PQ. So P squared equals 0.41 squared, which equals 0.17. When you square 0.41, that's what you get. So that's P squared. Q squared was given, so 0.35. Then 2PQ will be 2 times P, which is 0.41, times Q, which is 0.59, which will give you, do some math right now. So you do 2 times 0.41 times 0.59, which equals 0.48. So now you solve and see if you get the answer right. So you do P squared plus 2PQ plus Q squared equals 1. We already determined the values. So you do P squared, which is 0.17, plus 2PQ, which is 0.48, plus Q squared, which is 0.35, equals 1. And when you add them up, 0.17 times 0.48 plus, plus 0.35
equals 1.
Which will equal 1. So 1 equals 1. So you determined that for the homozygous dominant, you'll have 17% are homozygous dominant, 48% are heterozygous, and last but not least, 35% will be recessive. And this concludes our Hardy-Weinberg problem, which I never want to see on the test. If you don't want to put it in there, please don't.